Hello, grade 11s, and welcome to part 2 of question number 3. This question deals with your favorite type of quantitative aspects of chemical change question. That is a question on limiting reagent and percentage yield. So I know that sometimes you guys battle with these questions, but there's no need to battle. You just practice, and when you practice, you're going to make progress. Thank you so much once again for watching these videos, for taking your time to make your life a little bit easier, so that when you get into your exams, you don't need to panic and you can rest assured knowing that you've done all you can to make sure that things are going to go very, very well. So, always you start off by trying these problems and then you work along with me. Question 3.2 says the following balanced equation represents a redox reaction in which 8 grams of iron oxide Fe2O3 reacts with 38 grams of aluminium. And here is the balanced chemical equation given to us. They say the reaction runs to completion. Question 3.2.1 says, define the term limiting reagent. Please remember, another way of stating the word limiting reagent is to speak of limiting reactant. It means the same thing. Limiting reagent is just a little bit more fancy. And we say the limiting reagent is the substance that is used up completely during the reaction. Remember, the opposite, if you'd like to call that, of a limiting reagent is the reactant in excess, the one that will be left over. So you're baking a cake, you only have 2 eggs, but you have 5 liters of milk. You're going to use both eggs, but you're not going to use 5 liters of milk to bake the cake. So what is your limiting reagent? Your limiting reagent is the eggs. Your reactant in excess is going to be the milk. Because once you're done with your reaction, creating this cake or baking the cake, you're still going to have milk in its original form left over. On to question number 3.2.2. It says, which one is the limiting reagent? Is it iron oxide or aluminium? Justify the answer by suitable calculations. So in order to determine the limiting reagent, we're going to have to start off by determining the number of moles of aluminium and the number of moles of iron oxide. Once we have the number of moles, we're going to assume that one of these substances is the limiting reagent, and we're going to see how much of the other substance we need to react completely with that substance. So let's start off by calculating the number of moles of each substance. Okay, we start off with Fe2O3. The number of moles is equal to mass. Oh, we must always label this, please. So don't just write N of Fe2O3 is equal to mass divided by molar mass. The mass of the Fe2O3 is 8, and the molar mass of iron oxide we can calculate by saying 2 times the atomic mass of iron, which is 56, plus 3 times the atomic mass of oxygen, which is 16. And when we add that together, we get a complete or total molar mass of 160, not 80, 160. When we say 8 divided by 160, we get an answer of 0.05 mole on the dot. So that is the number of mole of iron oxide that we basically have in the cupboard, if you'd like to put it that way. Then we take a look at the other substance, which is the aluminium. We determine the number of moles of aluminium by taking its mass, which was given to us as 3.8. The molar mass, or atomic mass rather, of aluminium is given on the periodic table over here as 27. So we say 3.8 divided by 27, and we get a final answer of 0.14 mole. Okay, so there is your number of moles of each compound. Now that we have the number of moles of each compound, we need to make an assumption. So we're going to say, let's assume one of these substances is the limiting reagent. I, for now, am going to assume that iron oxide is the limiting reagent. That means all of this is going to react. If we make that assumption, then we can say iron to oxide to aluminium, according to the balanced chemical equation, react in a ratio of 1 to 2. So we write down 1 to 2. This is the recipe. Now, in the cupboard, we actually have 0.05 mole of iron oxide. The question is, how much aluminium is necessary for all of this iron oxide to react? So we say 1 times X is X, 2 times 0.05 is 0.1. Therefore, to react completely with the 0.01 mole of iron oxide, we're going to require the number of moles of aluminium to be 0.1 mole. When we take a look in the cupboard, we see we don't only have 0.1 mole, we have 0.14 mole. That means that we actually have enough aluminium available to react with all of the iron oxide, and our assumption is correct. So in the end, we say, therefore, the Fe2O3 is in fact the limiting reagent. The marks for this question are going to be awarded as follows. The question is out of 4 marks. So you're going to get number 1, a mark for your formula. We don't often still give marks for formulae. At this stage, we're trying to give more marks for the calculations than for the formulae, but we're going to award that mark. So 1 mark for your formula, 1 mark for substituting into this formula, 1 mark for the method that you use to calculate your number of moles of aluminium, and then 1 mark for the final answer that iron to oxide is the limiting reagent. Most of the time we give marks for the method as well, but in this case, since the calculation was relatively simple, it's only 4 marks for all of this working. Then we go on to question 3.2.3, which says, hence or otherwise, calculate the percentage yield if 4.76 grams of iron was formed. Now we must make sure that we can comprehend the information given to us correctly. They would like the percentage yield. Percentage yield is equal to the actual yield in mass divided by the theoretical yield multiplied by 100 to get the percentage. That is how we calculate percentage yield. What was given to us in this question? What is this 4.76 grams? It is the actual amount of iron that was formed. So this here is the actual yield. We need to determine the theoretical yield. So on paper, how much iron was supposed to form. In order to perform our calculations, we know that we must work with the limiting reagent. We may not use the reactant in excess. Using the reactant in excess is like assuming that we're going to make a number of cakes based on the 5 liters of milk that we have instead of the 2 eggs, okay? So you must use the limiting reagent. We only have 2 eggs and we can therefore only make 1 cake even though we have 5 liters of milk. So to determine the theoretical yield of the iron, we're going to be making use of the number of moles of iron oxide. We're going to say Fe2O3 to iron is a ratio of 1 to 2 according to the balanced chemical equation. So we're making use of stoichiometry. Remember, the ratios in the equation, the coefficients in the equation are only there for stoichiometry. We don't include it when we are trying to calculate things, for example, like the molar mass of the compound or anything of that sort. We only make use of those numbers, the coefficients, in stoichiometry. So iron 2 oxide, we calculated or determined the number of moles to be 0.05 moles. We don't know how many moles of iron is going to form. We say 1 times X is X, 2 times 0.05 is 0.1, and therefore we know the number of moles of iron that is going to form is 0.1 mole. But we don't need the number of moles, we need the mass of the iron. Mass is equal to number of moles multiplied by molar mass. That's going to be 0.1 multiplied by the atomic atomic mass of iron. The atomic mass of iron is 56. So we say 0.1 times 56. And we get an answer of 5.6 grams. This here is the theoretical mass of iron. This is what was supposed to form, but that is not what actually formed. What actually formed was 4.76 grams. So now we can determine the percentage yield. We say the percentage yield is going to equal to the actual yield 4.76 divided by the theoretical yield 5.6 multiplied by 100. When we plug this into our calculators, we find out that the percentage yield is 85%. And that is the final answer to this question. This question is out of 4 marks, so you're going to get 1 mark for your calculation or your number of moles of iron. You're going to get 1 mark for your substitution to calculate the mass of the iron, 1 mark for your method of calculating percentage yield, and 1 mark for your final answer. In grade 11s, this brings us to the end of this question, question 3.2. Please remember, question 3 is broken up into 3 parts. So there's 1 more video that you need to watch on question number 3. Please be sure to watch that video as well.